Hello everyone and welcome. In this video we are talking about what is faster, the Porsche Taycan Turbo S or the Tesla Model S Performance. Now Porsche says the Taycan Turbo S is good for 0 to 60 in 2.6 seconds and has a top speed of 161 miles per hour. Tesla says the Model S Performance is good for 0 to 60 in 2.4 seconds and has a top speed of 163 miles an hour. We're done, right? Tesla's faster. Not so fast. My TI-83 Plus disagrees. Cheap. Me? Nope. Sprung for the plus. So here's what I think. I think take the Porsche, take the Tesla, put them both at a stoplight. Which one's going to be quicker off the line? I think it's going to be the Porsche. And in this video, I'm going to explain why. So the first thing we're going to look at is wheel torque. Which one of these two vehicles has more torque at the wheels? And so both of these vehicles have two electric motors, one in the rear, one in the front. For the Porsche, there is a combined torque, Porsche claims, of 1,050 Newton meters. Now, thanks to David Tracy of Jalopnik, we know that the torque split is 610 Newton meters in the rear and 440 Newton meters in the front. Tesla, in their owner's manual, states that the Model S Performance has 720 Newton meters in the rear and 420 Newton meters up front. Now, wheel torque isn't just about how much torque the motor makes. You also have to pass that through a gearbox. In the case of the Porsche Turbo S, they actually have two gears. So first gear in the rear has a gear ratio of 15.563, super aggressive, and then the front gear ratio is 8.05. Now for the Tesla Model S, it's about 9.734 in the rear and 9.325 in the front. So if we want to look at wheel torque, total wheel torque for the vehicle, we take our torque, we multiply it by the gear ratio, and then we add the torque from the front, multiply that by the gear ratio. So we can compare the two here. So looking at the Turbo S, we do the math, and that comes out to 13,035 Newton meters. Now, Porsche states that the wheel torque of this Porsche Taycan is almost 12,000 Newton meters. So I'm assuming that's as a result of some losses that it will have through the drivetrain. So the theoretical being at 13,000 and then the actual being almost at 12,000 Newton meters. Now, for the Tesla here, the theoretical limit, multiplying this and then adding this multiplied right here, gives us 10,925 Newton meters. And then you'll of course have some losses. For the purpose of this video, we're going to pair these exact numbers rather than looking at the numbers with losses. And something to keep in mind here, remember when the Tesla Roadster came out, Elon hyped up quite a bit that it had 10,000 Newton meters of wheel torque. Well, Porsche is stating at the wheels they're going to have 12,000 Newton meters almost. So already more than what Elon claimed about the Tesla Roadster, which is not yet out. I suspect the Tesla Roadster will actually have more than 10,000 Newton meters if it's going to be as quick as Tesla claims it is going to be. So from here, we can see that the Porsche Taycan has a torque advantage. The thing that we don't know is it actually quicker? Because we have to take into consideration the size of the tires, we have to take into consideration the vehicle weight, and we have to take into consideration the torque curve. How long does this peak torque actually last in the Tesla versus the Taycan? And so that's what we're going to compare for the rest of this video. Moving on to wheels and tires, now what we're trying to figure out is what is the actual force that is pushing the vehicle. We know the wheel torque, but that doesn't tell us the force pushing the vehicle because we have yet another gearing mechanism, which is the size of our tires. So if we look at the torque being applied to the wheels, you can see that torque is a function of force multiplied by radius. So if we're trying to find the force at the wheels, then we have to take torque and divide it by our radius. Now, what does that mean? Well, that means if your radius is smaller, the force you'll be applying to the ground will be larger. And so we can look at the different sizes for the front and rear tires of both the Turbo S and the Tesla. You can see the Turbo S has wide 265s up front, 305s in the rear. The Tesla has 245s up front, 265s in the rear. So the Taycan does have noticeably wider tires, and the radiuses are going to be somewhat similar. So in the front, the Tesla is going to have a slight gearing advantage, 0.3524 meters versus the Porsche Taycan. In the rear has a slightly smaller radius on the Taycan, meaning it will have a slight gearing advantage. So what do we do to calculate the actual force at the wheels? Well, we take the wheel torque at the front, this multiplied by this, divide it by the radius at the front, this number right here, add that to the rear, and then that will give us our combined rating of the force that the Porsche Taycan Turbo S can actually push along with, theoretically, which is 36.4 kilonewtons. Do that same math for the Tesla based on its specs and its 10,925 Newton meters of torque, and you get 30.6 kilonewton force. So this is actually the Porsche here, a 19% greater peak force that it is capable of pushing this Taycan along with, which is quite a significant difference. Okay, so now let's determine the peak acceleration that's theoretically possible for each of these two vehicles. And here's where we run into a big problem with the Porsche. 2,323 kilograms. It's super heavy. Wait. Don't worry, it doesn't actually matter that all much because guess what? The Tesla at 2,241 kilograms is also super heavy. So if we want to calculate acceleration, we start off with our lovely equation, force equals mass times acceleration. From that, we derive acceleration equals force divided by mass. If you take that mass, multiply it by gravity, you can get your acceleration in G's. And so using the Porsche as our example here, we calculated 36,400 newtons for the force. We divide that by its mass multiplied by gravity, and we get 1.60 G's. Doing this same thing for the Tesla here, we calculated 30,600 newtons right over here. We divide that by 2241 multiplied by 9.81, and we get 1.39 G's. So even though the Porsche is heavier, still a significant difference in acceleration that it is capable of. Now, that doesn't mean it will actually put this down. We've got some assumptions here. So first of all, we're ignoring load transfer for this. Now, I did a little bit of math. It's not all that complicated to add this in. The thing is, both of these vehicles have very similar weight distributions. They're both about 50-50. So using load transfer doesn't change things all that much. So we're just going to ignore it for this video. We're also assuming there's no grip limit. We're looking at having infinite traction essentially in this video, which there does not exist in the real world. So can a tire out there, a street tire, put down 1.6 G's from 0 miles per hour? Unlikely with today's technology. So that is something that we will need to touch on. And then the other thing that we need to touch on here is that we have no RPM limit to our torque, meaning we have essentially infinite power. So that's the next thing we're going to get into here. But one of the things is going to be, okay, well, what about tires here? And so from a tire comparison, yes, the Porsche is heavier, which is worse, but it's only 3.6% heavier. And it has 15% wider tires in the rear and 8% wider tires up front. So I think from a grip standpoint, the Porsche will actually have the advantage, which is why I'm okay ignoring this grip limit here. Now let's move on to the torque curves. So Porsche actually provided Jalopnik with their torque curve, which is fascinating to look at, and it's actually really cool, the shift strategy that Porsche uses. So essentially, they allow that rear axle to remain in first gear all the way to 100 kilometers per hour. And then after that, it switches, giving them the best possible 0 to 60 times. So what we're looking at here on the left is torque up to 12,000 Newton meters. So here's total combined torque of the vehicle. You can see it starts to taper off at about 50 kilometers per hour or about 30 miles per hour. Here in purple, we have first gear torque for the rear axle. We have second gear torque for the rear axle. And then we have first gear torque, the only gear, for the front axle. So that blue is just the combination of whatever you're in. And as you can see, it's beneficial to remain in first gear up until you get to about 100 kilometers per hour. And then you switch over to that second gear for the rear, which if you are to be in, because of its ratio of 8.05, peak wheel torque acceleration G's in second gear, assuming you have all the torque available, is 1.03 G. So significantly lower once you switch over to second gear. Now, what we have here is an estimation of what's going on with Tesla. So we don't know. I haven't seen an accurate torque curve of what the Tesla Model S performance looks like. But one thing that is commonly true with electric motors is that you have peak torque exist all the way until you hit peak power, and then you start to have torque drop off. So if we assume that peak torque and peak horsepower occur at the same RPM, then we can calculate using that knowledge in the equation horsepower equals torque times RPM divided by 5252 to figure out what speed would this actually occur at. And yes, it's a guesstimate. We don't know for sure, but that speed is about 70 kilometers per hour, or about 43 miles per hour. For the purpose of this video, we're going to be very kind to Tesla, and we're just going to assume that it can maintain that peak torque for both motors all the way up to 100 kilometers per hour. Why? Because the Porsche is still going to be all right. So if we want to calculate how long does it take to get from 0 to 30 miles per hour or 0 to 60 miles per hour, in other words, 50 kilometers per hour or 100 kilometers per hour, we take the change in time is equal to the change in velocity divided by acceleration. So that's the equation we're using to calculate these times. Velocity is equal to acceleration multiplied by time. So the Porsche Taycan, because it's able to maintain that peak torque basically all the way until 30 miles per hour, it's getting those peak Gs that entire duration. So its 0 to 30 time is 0.86 seconds versus the Tesla, which is going to be at 0.98 seconds. And so here's why you start to see that, yes, I do believe at a stoplight, the Porsche Taycan is going to win the race. Now, unfortunately, that Porsche Taycan's torque starts to drop off at about 50 kilometers per hour. It's quite a steep drop off, and so we can still calculate, well, what is its 0 to 60 going to be, assuming that it reaches its final torque of about 1.03 Gs at the end. So it's starting at about 1.6 when it's at 50 kilometers per hour. Once it gets to 100 kilometers per hour, then we're down to about 1.03 Gs. So we're going to take the average of that, and doing the math using that average, we get a 0 to 60 time of 1.90. Now remember, this is theoretical. It doesn't include aerodynamic losses, powertrain losses, that kind of thing. But we're doing this comparing theoretical to theoretical to see which one could actually be quicker. Doing that same math for the Tesla, again, assuming it has its peak torque the whole way up to 60 miles per hour, we get 1.96 seconds. So in either scenario here, off the line, it's going to be a bit quicker. To 60, I believe it will actually still be quicker, and then beyond that, it is very difficult to predict because we don't know what's going to be happening with each of the motors, with the aerodynamics, with the efficiency of the motors. There's all kinds of variables that are going to start to come into play after you get past 60 miles per hour or about 100 kilometers per hour. So what have we learned? Well, if there's going to be a stoplight race between a Tesla Model S Performance and a Porsche Taycan Turbo S, then, assuming there's not all that much grip outside, it's going to be a dead even race. Assuming there is plenty of grip for both of these to be able to do their thing, the Taycan is going to get the edge at a stoplight race, up to 30 miles per hour for sure, and then past that it starts to get questionable. We don't really know what's going to go on. And so now this is the moment where all of you Tesla fanatics can happily bring up tri-motor and plaid mode and all that other stuff. But regardless, I think very cool to look at, using a transmission. If you add these two numbers together, it is less than these two numbers right here, and yet it's able to put down more wheel torque through gearing through using a transmission. So by using that two-speed transmission, there are performance advantages of doing so, and I think that's super cool and super cool to analyze regardless of who actually is the quicker car out there. So thank you all so much for watching, and if you have any questions or comments, of course, feel free to leave them below.